Hi, we're here within the Advanced Cooling Solutions, and we'll be talking about the ecosystem enabling of liquid cooling ingredients. And my name is Jessica Goldbrand, and I work for Intel.
And I'm Mark Springer. I'm a technical lead within Intel, and I'll be talking about universal quick disconnects.
So let's dig into the presentation. The outline of the presentation is we're going to give an introduction first, then talk about the ecosystem enabling, and then specifically go into more detail in regards to the ingredients that we are enabling. And those are the cooling fluid, the universal quick disconnect, the coolant distribution unit, and after that we're going to summarize this presentation. So an intro to liquid cooling. Why liquid cooling, right? It's really because we have a continuous demand for increased compute power. And it's with that also comes increased power and power density of the components themselves. And in order to be able to cool them and meet the thermal requirements, we need more efficient cooling solutions than air cooling. And one of those cooling solutions is liquid cooling, because it allows for that greater cooling capability as well as higher density solutions. So Intel is working with suppliers to enable liquid cooling ingredients to really increase the availability. So when liquid cooling is needed to cool the high power components, the ingredients should already be there in the ecosystem. This also lowers the risk for liquid cooling solutions, and can also allow for generational and system supplier compatibility, which is something that Mark will be talking about when it comes to universal quick disconnects. And it can also allow faster time to market opportunity if all the ingredients are already in place within the ecosystem. So within Intel's ecosystem enabling, we're focusing on the manifold distributed liquid cooling ingredients, and specifically the TCS loop, which is the technology cooling systems loop. And this cooling loop, it goes from the CDU, so the coolant distribution unit, through the rack manifold, through the IT equipment, to the return manifold, and back to the CDU again. So this is the cooling loop that we have been focusing on. And within that cooling loop, we have 3 different ingredients that we have been investigating. And those are the cooling fluid itself, the coolant distribution unit, liquid to liquid CDU, and then the universal quick disconnect, or the UQD as we're calling it. Before I dig into a little bit more of the details here, I really want to just mention a few caveats. And it's really that within Intel, yes, we have carried out a lot of work within Intel as well as with the suppliers to ensure that there's a robustness of the ingredients, but please don't treat this as that these ingredients have been fully vetted or validated by Intel, because each of the liquid cooling solutions are really unique. So you need to make sure that each solution really works. And so it is really falls within the responsibility of the OEMs and or the ODMs to ensure that the quality and reliability of the systems are there that utilize these ingredients that we're going to talk about. And with that, I also want to say that today, since there are no standard methodologies really within the liquid cooling community of how to test this, Intel also targets to contribute to test methodologies to OCP. So if we're jumping into the first ingredient, which is the cooling fluid. And it's talking about really here the wetted materials. So those are all the materials that are in direct contact with the cooling liquid. And we really need to ensure that there's compatibility between the cooling liquid and all the wetted materials that are being used. This is extremely important. Otherwise, there could be issues that occur due to this compatibility. So really the quality requirements as well needs to be in place. They need to be determined because there can be instances of corrosion, fouling, scaling, microbial growth within the liquid as well. And you need to know what those quality requirements are so that your liquid cooling solution works as it's intended to do. And you also need to follow really the maintenance of the fluid as provided by the manufacturer themselves. For the cooling fluid, there are many different choices for liquids that can be used. You can have water with additives, you can have glycol-based liquids, you can have dielectric liquids or refrigerants. What we have been focusing on within Intel is glycol-based and particularly propylene glycol-based liquids. So we've been focusing on the propylene glycol with 55% glycol and 25% glycol. The reason for that is really the fluid operational range that we need to adhere to. So for shipping and storage, we need to make sure that the liquid is not freezing if we go below minus 40 Celsius. And this is why we have to go to a 55% glycol level. So this is really the liquid that we would use for shipping and storage. And then the operational temperature range goes between 17 Celsius up to 65 Celsius. And here we're following the ASHRAE recommendation of not going below 17 Celsius to avoid condensation within the IT equipment itself. So that's what we've been doing when it comes to cooling fluids. And we worked then with multiple fluid vendors and test houses to make sure that we don't see any corrosion issues when it comes to these liquids and welded materials. And the fluid suppliers that we worked with are two. It's Dow and it's Huntsman Chemicals. And the fluid names then, so for Dow, we have the Dow Frost LC25 for the 25% propylene glycol level, and for the PG55 for Dow, we have Dow Frost LC55. For Huntsman Chemicals, for the PG25 liquid, we have Jeff Cool ISF 25, and for the 55%, Jeff Cool ISF 55. And the reason why we have selected these liquids are that because they are globally available in 47 different countries. I do want to highlight, though, that these fluids are not interchangeable. You don't want to mix one fluid with the other. That's not a good practice and should be avoided. But I just want to mention that because sometimes we are getting questions in regards to that. And we also then been documenting the welded materials compatibility list. So we have a list here of welded materials. This list is still being updated. We're still working on it, and we're currently working on adding the bracing materials, and we're targeting to add those on by Q3 of this year at the regional summit. And the testing that we're doing, so I said that we're having ongoing testing, and we've been testing for 180 days now, and you see a picture on this slide here from the lab where we have the test set up. And to the right, you can see a sketch of what that test setup looks like. So you have a supply manifold that goes into a quick disconnector. Then you have two cold plates in series. And the fluid is going out through the quick disconnect into the return manifold. The materials that we are having in this fluid loop are stainless steel, it's copper, FEP, Viton, EPDM, and bracing materials. So this is the testing that we're currently doing now. And the parameters that we're tracking here throughout the testing period is pressure, fluid and case temperature, and flow rates. For the fluid characteristics, it's pH level, it's the conductivity, and then different concentrations in the liquid itself. For example, corrosion inhibitors and particles that we're tracking here as well. And with that, I'm going to hand over to Mark that will talk about the universal quick disconnects.
Okay, thank you. As Jessica mentioned, the universal quick disconnect or the quick disconnect is a critical function of the fluid cooling loop. The connection between the cabinet manifold and the IT equipment is where that connector lies. And that connector can be disconnected while the fluid loop is running, and it will stop flow in both directions. That allows the suppliers or the data center owners to replace equipment without shutting down the entire loop. So it is a very critical part within the fluid loop. It's also a very complex part because in the ecosystem it spans multiple suppliers, because suppliers that are delivering IT equipment, probably not the same suppliers delivering cabinet equipment. So Intel took a look at that and developed an initiative to make it universal, similar to a plug you'd find in electricity. This is the plug that puts the system in place. We did this in collaboration with our industry partners, and the objectives of this initiative are: one, to specify the interface dimensions, a minimum specification of those interface dimensions; two, to define the minimum requirements for performance for that quick disconnect; and three, to work with multi-suppliers to ensure there's global and readily available parts. The handmade quick disconnect, which is the first phase of this program, second phase of the program will be a blind mate quick disconnect. And this is, if you're looking at this image, it is out of the requirements document. You can see that when I say minimum set of definitions to ensure interchangeability or interface, you can see that there's a lot of definition here, but no internal definition. The definition really is a function of the interface together. So we don't limit the suppliers with respect to how they are going to do all the internal. Really, it's their IP and their expertise, as well as the external dimensions and even how the locking mechanism might work. The consequence of this is that universal quick disconnects may look very similar on the plug side, but might look a little different on the socket side. So we ensure that each of these universal quick disconnects have the appropriate markings on them, and you'll find interchangeable parts within the sizes of UQDO2s, UQDO4s, UQDO6s, and UQDO8s. And you can see at the table there the various sizes and dimensions that we have with this first phase. These are our UQD suppliers or partners: Abbott, John Hunn, CPC, Fujikura, Parker, and Staubli. Now, these suppliers are all developing UQDs in conjunction with this requirements document that we're getting input from them on. And as you noticed in the image, there's a lot of parts that are not defined that will be defined by the suppliers to allow suppliers to deliver parts that are that can be used based on specifications from the data center owners to meet their needs. So we've been involved in interchangeability validation with the Universal Quick Disconnects. We have completed the UQDO4 interchangeability validation. The parts have been tested for fit, form, and function. We validated the CV values for all the parts. There's a table on the right there that shows all the various CV values that we've calculated for the Universal Quick Disconnects. Those parts, as you can see, supplier B matched with all the other suppliers in the testing, have delivered us parts. We've tested their CV values. You can see there's a range there that we have in those CV values. All the suppliers have met the minimum requirement of 0.8. So the testing is going well, and we're doing ongoing testing with UQDO2s now. The locking mechanism also has been validated in terms of connecting those connectors together and then pressurizing them at high pressures to ensure that the locking mechanisms don't fail. And so that testing has been completed, and that is the extent of validation we've done on UQDO4s, and UQDO2s are in process. Now, along with that range of CV values that we determined, you can see the graph on the right showing the CV values or pressure delta P curve. And you can see that they do, as the flow gets larger, the spread of the delta P range gets wider. So we've done a lot of analysis and done some sensitivity testing, and we're testing, or our analysis goes in the range of the UQD values that we tested, the lower range of 0.89 all the way up to the maximum range of 1.38. The way we did this analysis, we took a representative system that we're working on currently, and if you can imagine the UQDs in a system, maybe all of those UQDs attached to the systems all are of the higher value CV, and then you take a system and switch one out with the lower value CV. Now you might think that that particular system might get starved for flow because of the CV values, and all of these systems were analyzed based on cold plate type design cooling loops. Turns out that the cooling loops and the cold plates, the delta P's across those components are orders of magnitude higher than what you find with the UQD. So the impact of the UQD on the system when interchange is very minimal. And when we look at it from a performance standpoint, switching them out, as I've described, we see a temperature difference at the processor of less than half a degree. So very minimal impact to having a wide range of UQDs because of the very low delta P across the QD relative to the other components in the system. So UQDs will continue to finish off the requirements document for UQD02s through 06s, and that'll be delivered to OCP or contributed to OCP. We'll complete that system level analysis that I just showed you, and we will be publishing that. We will deliver interchangeable test data for the UQD02s, and a target date for that completion is Q2 this year. Blind mates are ongoing now, and working with partners currently to define the blind mate geometry, and we're targeting completion in Q3 of this year.
Thank you. Okay, so now we're jumping into the third and last component here for our ecosystem enabling efforts, and it's the CDU itself. So here's the liquid-to-liquid in-rack CDU, which is what we've been focusing on. And it's just want to highlight here, too, that it's really important to work with the CDU suppliers to ensure material compatibility with the cooling fluid. The reason why I say that is that CDUs generally for us are black boxes. They come from the suppliers, and we don't know what materials that are used in those. So it's very important to work with the CDU suppliers to determine the wetted materials there, so you're not introducing a material that is not compatible with the fluid that you're using. The two CDU suppliers that we've been working with here that has performed some testing as well are the Nortec and the Coolit. So for Nortec, one CDU model example that have checked for material compatibility is the MCD5U, and for Coolit, it's the CHX80 CDU that they have worked on for and checked material compatibility. There's some ongoing work as well going on now, and it's with 4 APAC CDU suppliers and 1 additional North American CDU supplier. And we again target to share this information and give an update in Q3 of this year at the regional summit. So the material compatibility was checked for with the 2 PG25 fluids for these different model examples here for the CDU. And with that, I'm jumping to the summary. So we've been talking about the ecosystem enabling of liquid cooling ingredients in the TCS loop. We talked about the cooling fluid, how important it is that you have material compatibility with the wetted materials. And we also talked about the test methodology that we're using to ensure that we have that compatibility in place. We talked about, or Mark talked about, the universal quick disconnects, the interchangeability validation, the flow distribution sensitivity, and for the CDUs, we've given an update on that. We're looking at several more suppliers that that we're currently working with. And with that, I really want to again call to action here. Please be active within the advanced cooling solution work streams, and specifically with the cold plate work stream. We meet every second Wednesday of the month at 8 a.m. Pacific time. Please call in, sign up to the emails, and contribute and participate. And with that, I would like to say thank you.
Yeah, hi, there's a question that came through regarding QDs.
Okay. Yep. Thank you for attending, everyone. I think I was on mute there. I wanted to start off with just talking about the liquid selection. We've had a little bit of a discussion going on here in the chat window. And it's really the reason why we're selecting the propylene glycol is because of meeting the temperature requirements that we have. We're not saying, that, of course, that everyone should be using propylene glycol. There's a lot of other liquids that are out there, but we have been focusing on doing the testing around the propylene glycol liquids. And we're welcoming anyone else to feel free to really provide additional information of what are materials that are compatible with specific liquids. And we welcome that information from others to contribute to OCP. All that we're doing here is really of sharing of the process that we are using, and we want to make sure as well, right, that we have as mature liquid-cooled solutions as possible when we, since, I mean, it's not necessarily rocket science here, right? We see that power levels are going up, liquid cooling will be needed. How do we make sure that we have as mature solutions as possible when the liquid cooling is required? So that's really what I would like to say in regards to the liquids. And then, Mark, there were some questions in regards to QDs. Do you want to start off?
Yeah, sure. So there was a question, says, are handmate and blindmate QDs also interchangeable? So there is a universal quick disconnect project for both blindmate and handmate. And so, yes, they will be interchangeable. The second part of that question is how often would one be used versus the other? And it's just really a function of the data center requirements. And so many servers are blindmate servers, and many have handmate connections. So I don't know the exact percent split there, but yeah, they would both be used. There's a question also, the UKITI project is open to participate. So we will be publishing the UKITI spec this quarter with the dimensions as well as for both the handmate and blindmate. So open to inputs, but yeah, the project is closed relative to having any participants.
Yep, what we can say in regards to that, right, is that the contributions are expected according to the timeline that Mark was presenting. Then for the target date for contribution for the handmate in Q2 and for blind mate end of Q3.
Mm-hmm.
And okay, would it be possible to get the chemistry from your suppliers without the glycol? That's really a question that I cannot answer. I would recommend contacting the suppliers directly and work with them. It's the fluids, of course, is their secret sauce in what the chemistry is around that. So I would recommend reaching out to the suppliers there.
And there's a question regarding hose and tubing requirements specific to universal quick disconnect. We do specify at least a minimum option on one termination, being a push lock tube for the hose, but that's about it. So you would work directly with the supplier to if you had any requirements that were outside of that minimum specification.
Sounds good. And yeah, so we have been presenting for a while now in OCP of our updates, giving updates of how the liquid cooling ecosystem enabling efforts are going and what we're targeting to contribute and what we're learning along the way. So really appreciate everyone attending and listening in. And if you have any other questions that are coming up afterwards, please feel free to reach out to either me or Mark, and we'd be happy to discuss those as well. And for now, thank you so much for attending. Stay safe, stay healthy, and hope to see you guys soon. Okay, thank you.